Hello friends, as part of continuation to data warehouse concepts from my last video, today I am going to talk about data warehouse implementation and related terminologies with respect to same. First of all, let's see what are the database we actually work with data warehouse. There are basically two types of databases we actually use. First is RDBMS, which is Relational Database Management System, and MDDB, which is Multidimensional Database. RDBMS is based on relational model and is a basis of SQL for modern database systems like MS SQL Server, IBM DB2, Oracle MySQL, and Microsoft Access. Multidimensional database are frequently created using input from the existing relational database only. It's a type of database that is optimized for data warehouse and online analytical processing tools. Now let us see the use of RDBMS in the warehousing architecture. Data warehouses are built on relational database technology, online analytical processing tools, then used to interact directly with the relational data warehouse or a relational data mart. Here the data mart is typically a subset of enterprise data warehouse like sales, marketing, finance, a particular department with respect to their own specific data subset in a particular organization. Now let us see the multidimensional database implementation in warehouse. The data extracted from the relational data warehouse is placed in multidimensional data structures to reflect the multidimensional nature of the data. Multidimensional OLAP tools run against the multidimensional server rather than against the data warehouse. There is also a combination of the two data warehouse implementation which we already discussed. It's known as tiered data warehouse architecture. The enterprise here is free to mix and match the database technologies we just discussed, depending on the scale and size of data warehouse. First one is ROLAP tool, ROLAP, acts as a front end, which then run directly against the relational data warehouse, are used whenever the queries are fairly simple and when the administration overhead that coming with a multidimensional tool is not justified for a particular user base. Multidimensional database are here acting as data marts, and a specific multidimensional front-end application just query the contents to the database MDDB. Data marts here also run used as a relational database framework, in which case here the ROLAP front end will work. Now let's see the comparison of multidimensional database along with the relational database. First one is size. Second, on the basis of volatility of the source data, aggregate strategy, type of users, and the normalization part. These are the five most important aspects on the basis of which we can compare the two. Let's see size. Multidimensional databases are limited in size. Although the size limit has not been increased gradually over the last few years, but in the mid-90s it was only 10 gigabytes of data in a hypercube, and today it is almost 100 gigabytes of data which is being stored in the hypercube. But despite this improvement, the large data warehouse is still better served by only relational frontends running against the high performing and scalable relational database only. Second term is volatility. Volatility is better handled by the relational technology. Multidimensional data in hypercubes takes a long time to load and update. So the time required to constantly load and update the multidimensional data may prevent the enterprise to load new data, which is almost often desirable. Third one is the aggregated strategy. Multidimensional hypercubes support aggregation better, but this advantage will disappear sometime as relational database improve their support to aggregate navigation. Fourth term is type of users. Power users prefers functionality which is there in the multidimensional OLAP tools. But the users who require broad views of enterprise data, they generally prefer to have relational OLAP tool. Normalization. RDBMS is highly normalized, but MDDB on the other hand is highly denormalized. Now let us now discuss some of the key concepts used on the top of data warehouse implementation. Data modeling. Once the data warehouse is developed, the data modeling is the business need, the next business need. What is it? What is data modeling? It's generalized logical relationship among the tables only. It optimizes the performance, it minimizes the cost, it facilitates system documentation and maintenance. Now, so what are the types of data model which we actually use in data warehouse? There are basically three types: denormalized data model, normalized data model, and dimensional data model. Now let us understand each in detail. Let's take an example of this table. Here it is a denormalized model because all the data is in a single table and also the data redundancy is there. In this example you will find that there are directly correlated attributes like product number, product category. They are repeated in each row. This is an example of denormalized model. Now take a view on normalized data model. Let's take an example of this table structures. Here you will find that there are different tables with respect to different areas of representation. So the data is broken up into multiple tables. It's a normalized model. It is often used in transaction based systems, like here it is an order entry example. Normalized data model is insert optimized. Here if you take an example here itself, a new transaction line involves gathering only the 5 data items in the transaction line table. No other attribute lookup is required. It reduces redundancy. For example, here the product category table will not be repeated for each transaction. There are less changes or less impact on the changes with respect to the database. You can see here if a product category changes, only the product table needs to be changed. So no impact on the other tables. They are just interconnected with the help of joins and relationships. But there is a disadvantage too, that it increases query complexity. As you can see, there are several tables which are already related, joined to each other. So in order to answer simple business queries also, there are different complexities, queries, joins, relationships will be involved. Now the third type of data model is dimensional data model, which will be my scope of presentation in my next video. We will be completely covering dimensional data model in our next video. So if you are having any training or queries, in the meantime you can ask me on my mail ID, which is cognos.piyush@gmail.com, or simply visit my blog at piyushcognos.blogspot.in. Thank you.